Hello everyone, welcome to this session. So in this session, we will first talk about some basics. Then we will go to the following sessions to prepare the data well, right? So let's first see the Gaussian distribution. So this is a very important concept. So as you know, we have already seen the uniform distribution. Remember in the first course of this specialization, the MATLAB part, and we have used the rand function to generate uniformly distributed random data points, right? So for uniform distribution, we can consider that, so for space, if we cut the space to several parts, and each part have the same area, so ideally, the points located in each of the part should be the same. So that is uniformly distributed. So for example, in this figure, let's just cut the space by the two axes, so 4 parts. So we can see in each part, the number of points is similar. So ideally, it should be the same. So this is uniformly distributed. But considering Gaussian distributed on the left figure, we find the things is different. So if we consider the mean or the average is a 0, 0 point, then we can find that using different radius, then we can draw different circles. So in the nearest to the to the average circle, this one there are quite a few points, and while it grows, when the circles becomes larger, the points located are smaller. The number of points that is located there are smaller, right? So we can find that by Gaussian distribution, where the data near the mean are more frequently appeared than the data far from the mean. So this is the basic thing of a Gaussian distribution. So if we make it more mathematically, we introduce a concept we call the probability density function. So this is a function of a Gaussian distribution. So what does this function tells us? So now there is a random variable. So when the random variable equals to x, so this fx, the function value, tells us the likelihood of the x appears. So let's see in this formula, the mu is average or the mean, the sigma is a standard deviation. So if we want to see it more clearly, we can draw a figure. As you can see from the figure, the x-axis, we go from the mu minus 3 sigma to mu add 3 sigma. So this is the x value. And for each of the x value, there is a probability density, tell me the likelihood, right? So from this figure, we can make some observations. So first of all, we can see that the probability distribution is symmetric. So if we draw a line about the mean, so we can see the left-hand side and the right-hand side, they are symmetry, right? So this is the first thing. The second is that we can find out the data near the average or the mean, mu, are much more than the other parts. So if we can see within 1 sigma, so all the data, consider all the data is 100%. So within 1 sigma, the data is 68%. And within 2 sigma is more than 95%. And 3 sigma is already 99.73%. So this means that outside 3 sigma, there are data points, but they are very few, right? So this is a Gaussian distribution. The Gaussian distribution is the most widely used distribution in real life. So for example, your score. So your score won't be uniformly distributed from 0 to 100, right? Instead, around the passing grade, there are many people. And the very high score and the very low score, those are very little. So that's why we call it a normal distribution, the normally happened distribution, right? So after introducing the Gaussian distribution, we introduce another concept. We call it skewness. So if we consider this is a probability density function, if the skewness equals to 0, we should see it's a symmetric curve, right? So But if we have a positive skewness or negative skewness, we will find that the curve is different. So if it's a negative skewness, we can see that the tail is longer on the left hand side. Otherwise, for positive skewness, the tail is longer on the right hand side, right? So the Gaussian distribution, we can think that this one is symmetrical. So this is the skewness is 0. But there are many data that their skewness is not 0, and there are some have a very strong skewness. So later we will see how to handle that. The next concept, we have already seen the outliers. So we can see there is a data, and this data is, if we see it, we can see it's rather different from the others, right? So then we can draw this data in the figure, so we can draw it here. So between 0 and 4 is like this. So it looks like a Gaussian distribution, right? Yeah. But there is one outlier, clearly. This is here. So this one is far from the other data, so it's outliers, right? So using the data with outliers for some machine learning algorithms that is sensitive to that, this will highly affect the result. So we need to identify the outliers and remove them. The question is that how can we automatically detect them and remove them, right? So we will discuss it in the next session. Okay, thank you very much. Bye-bye.